I'm just going to talk about 3D printing and what we can use it with in our model railways, but mainly I'm going to talk about FDM printing, which is, in layman terms, is fused deposit material or modeling, 3D printing. And I'm thinking about it and reviewing how to get started with it, because it's not complicated, it's not difficult. So what is fused deposit modeling, FDM? Well, fused deposit modeling, or FDM for short, is a material extrusion method of additive manufacturing where materials are extruded through a nozzle and joined together to create 3D objects. A bit like your wife or your partner or your daughter doing icing on the icing cake. It's just a controlled method of doing that. A typical FDM 3D printer, therefore, takes a polymer-based filament. I think the misconception here is plastic. No, it's not plastic. Some of it's not plastic. Some of it's, like PLA, is starch-based. So it forces it through a heated nozzle, which melts the material, and then deposits it in 2D layers on the build platform. And while still warm, these layers fuse with each other to make a 3D part. So in effect, you've got a filament spool, you've got a stepper motor controlling the feed rate, and you're just depositing it on the build plate that moves in the X and Y and Z direction. What filament can you use? Well, depends on your machine. Maximum hot end temperature, that's the temperature of the nozzle, the heated bit before the nozzle. The bed temperature, you've always got to have a warm, nearly always a warm bed, because things need to stick. The bed material, you could have a flexible steel plate, you could have a glass bed, and nozzle material, because some filaments are abrasive. As you can see from the table, generally I print in either PLA or PLA plus. Temperature is about 190 to 225, depending on which I'm using. I tend to just stick with one temperature, 225, and build plate is always 60 degrees. But it does say no heat, but I've never printed without any heat. And generally, the more expensive your 3D printer is, it will print as standard more of these different types of filament. You can have ABS, you can have PETG, you have wood. There's even marble down there. I've never seen that done. But what can I print for my railway? Well, supports for my Merg PCBs, pocket money kits, etc., servo mounts, rolling stock, bridges, buildings, cases, wagon loads, platforms. It is entirely left to your imagination, as there are so many things you can draw and print. You no longer need bits of wood and plastic glued together as a one-off. You know, you can do, it's just down to your own imagination. This is John Holmes. This is the leader of the 3DC. This is done on a very basic budget 3D printer. And now he's created, this is in 00, and he's got some software. He can do the stone courses, so it courses properly, do the windows and everything else. And it's done in panels and it's stuck together. PLA is really good because it's easy to stick together. Let's take an example. You want to model something that's existing. You can take your photographs and you can create your side of the building and you can print it and you get an exact copy of what's there. This is another gentleman. This is Jonathan Duffert. This is off a site called Thingiverse. This is a free site. Now, he's got 75 different designs of wagons, loads that are free to download for you to print. Doesn't matter what scale, if you're in O or double O, you can scale up or down with your slicer to get whatever you want. But a lot of these will not print very well on an FDM. You will have to use a resin printer. But again, resin printers are quite reasonable. For less than £200, you get a very good setup. If you look on the 3D SIG and see some of the buildings that Eddie's done in his layout, he's 3D printed everything on his FDM and his resin printer, and they're both just basic machines. That's an example what I'm messing around with. This is it's a shuttle. As you can see, everything blue is 3D printed. So I've got a book converter, it's in its own 3D printed case. I've got a Pico with an IO board, it's sat on a 3D printed mount I screw down. The relays, controller, totties, even the little pull for the points. I've designed one, it could go even smaller than that, but that was my first attempt and I liked it, so I kept it like that. I've got a Servo 1R with its servo mounted on its own mount. I've even done one for the easy points as well, to the same, so the servo is mounted with the board. Very simple. That's roughly what I use mine for. Now, how do I create a 3D model for printing? Well, as you can see, you can go and get somebody else, or somebody's probably already drawn it and provided an STL, and you can use that. Well, you need a 3D drawing package that can export STL files. Now, the STL is the file that your machine requires to print. Now, there's three of the obvious candidates. Fusion 360, favorite of many, not good at creating buildings. And Autodesk are in full control of the updates. And it's Autodesk rival to SolidWorks. So Fusion is a very, very good program. I personally don't like it. And I use Autodesk products in my day job, 3D, and I can't get on with it at all. But that's not to say other people can't get on with it. And then Autodesk do another thing, another free one called Tinkercad. Now they've purchased this. It's very basic, but can produce very good models. Very easy to edit if you want to make some changes. Like you've done a test print and it doesn't work, or it's not what you wanted. Tinkercad is easy to edit. Very simple. I presume that the kids, grandkids, or kids use this at school, or it's an online program. Both those programs are online. And then the one everybody's heard about is SketchUp. Now, SketchUp is easy to learn. You recommend you do a search if you want to use SketchUp. Is SketchUp Mate 2017? You will have to go on the internet and look for that, because it's not on the Trimble website to download anymore. And then you can add the masonry add-on. So it's creating buildings, bridges, viaducts, retaining walls. We've even seen one gentleman do it in N with the bricks. He's even managed to print the bricks with the bed joints and the perps, with perps, which is the vertical joints. And it can do a lot more. It's very, very flexible. There's a lot of YouTube content about SketchUp. My personal favorite of the three, because it's very good for editing and lots of features. And I do recommend that you look at the 3D SIG and look at some of the stuff, and look at Merg TV. And Eddie has done a thing on SketchUp. He's done loco bodies. He's done all sorts. And yeah, it's a game changer. Anyway, this is SketchUp Online. Now, this is what you get this in. This will work in your browser. Now, that's my base from my book converter that you saw in blue. So I modeled that, and model in SketchUp is like you've got a block of wood, and then you get your saw and your chisel, and you cut your bits out, and you end up with that. That is a simplistic term of how you do it. Now, you can always modify that to suit other PCBs if you want. And once you've drawn it, that's it. You can keep using it. And I have a standard mounting for a PCB, and I just stretch it about to suit what it's going to fit. And, you know, it's really good. So then, how do I get it into my printer? Well, on the SketchUp make, you can download it. You then download it as an STL to your local machine. You can also, SketchUp will also import STLs from other people. And then you can go on then and modify them to what you want. So it gives you a lot of options. And now you need to slice your STL file to convert it into commands your 3D printer understands. So it's like taking a saw and sawing it off in levels, or like a multi-story building, and you've got the first floor, second floor, third floor, fourth floor, fifth floor. And that's how your printer works. It slices at these points. Now, Common Slicer software, it's all free. There's no money involved. So I'm just going to talk about two. I've tried both. Now, Cura is open source. A lot of the machine manufacturers will package Cura with their machine for to use. Nice slicing software, as you can see in the image. Somebody sliced a pipe connection. Yeah, I've done stuff at home. We needed a bracket for something, so I just 3D printed it. So there's other options. And then the Prusa slicer. You don't have to have a Prusa printer to use their slicer anymore. They've made their slicer available to all people's different manufacturers, different machines. My slicer of choice gives the best results, and it can be tweaked to rectify problems. So you've got your slicer. Now what's the next stage? Well, with a Prusa slicer, it's import, and then it's import your STL. So you've downloaded your STL, and you've got that. That's my Ender 3 bed. And there we have, that's the book converter base brought in, and it's sat on my print bed. Now, we got a problem. It's got some errors. Not uncommon. But if you've got Windows 10, 11, you can just right click that, and it will, and Prusa Slicer will fix all these errors automatically. So you'll get near a perfect print. And then there we are, it's sliced. So there, that's showing all the layers, and they're the layers up there. So if you wanted to change color, say halfway up, you can do that. How do I get it into my printer? Well, you can save it to disk. If your printer takes a SD card, you can save it to disk and put it on your SD card, and then go over and put it in your printer. Or you can be very crafty, and if you've got Octopi installed on a Raspberry Pi connected to your machine, you can just click this button here, and it will send this direct to your Raspberry Pi. It will then take charge of printing. And then you can switch your PC off. You don't have to have your PC on anymore. Common 3D printing problems. I've had a lot of this warping. while heating thermoplastics expand and shrink again when they cool down and return to a solid. This transformation creates some movement in extruded plastics, which is the root of 3D print warping. And yeah, and it's not good. I've had a lot of that, and it's took me a long time to get it sorted. Well, until I found out about use adhesives. PVP glue stick. This is like Pritt stick, or the glue that your kids, your grandkids use at school. That's on a glass bed is one solution. The only trouble is it comes too well stuck. So unbeknown to my wife, we have to keep one of the shelves clear in the freezer so I can take the glass bed off and put it in the freezer for 20 minutes, and then they just fall off. But you don't get any of this. Then you also going to have issues, probably your print not sticking to the bed. Yeah, well, level the bed. Your bed has got to be level. Clean the bed. Finger marks can leave grease on the bed. Tend not to use IPA, because I think, in my experience, if your bed has got a coating on it, IPA can remove that coating. So generally, I just use warm water, or warm water with a bit of washing up liquid. You can use a brim or raft in your slicer. So that means is that your model you want, the print, you can put a little brim around the outside of the bottom on the first layer to help it stick to the bed. Or you can put it on a raft. So it's a big raft. So you've got a raft. That raft will just peel off. And again, PVP adhesive on a glass bed. Also, check the temperature for your filament and adjust if necessary. Filaments have a set temperature, PLA, PLA plus. I work at about 205, which is in the range for both. Wet filament. Now, we never consider this. It's your printer sat in your modeling room at home. But unfortunately, different filaments absorb moisture at different rates. And there are a few common signs that you've got a wet spool. If your hearing's good, popping or cracking sounds when extruding. Severely reduced part strength and layer adhesion. Uneven extrusion lines. That means when you look at it, the lines are uneven. Severe stringing, blobbing or oozing. Now you see stringing, if you're going from, your nozzle is going from one point to another, it's got to travel a distance where it prints again. You'll see very thin lines of filament. That is due to uncharacteristic texture or fuzzy surface on print. What do you have to do? Well, store your filament. Plastic bucket you get with the bird food in, you know, the one you get at the hardware store, where it's got 40 fat balls in for the bird feeder. Get one of them. Either put some dry salt in a bowl, in a small cup in there, or some silica gel crystals that you can revitalize, and that will keep your filament dry. And you can just dry your salt in the oven or the microwave, get rid of the moisture again and start again. Cheap. You can buy a dryer to keep your filament dry, or put it in the oven for hours to dry it out on very low heat. But you can see what the issue is with wet filament. Now, another thing that's quite common is what we call elephant's foot. Is that, as you can see from the image, that the first layer is just oozed to create an elephant's foot type. Again, first thing is to level the bed and adjust your nozzle. Lower the bed temperature, because your bed is always heated. Print with a raft. You could add chamfers to your model. That means chamfer the bottom edge. Or if you find it in your slicer, there's an adaptive elephant's foot compensation in your slicer. So your slicer will compensate from that and stop that happening. Now, how accurate is it? Well, I had to do a test, me, a test cube. So I did a test cube on my direct drive Ender 3 Pro. Budget printer, I've just put a direct drive on it and see if it would beat Creality's, who's the manufacturer's conservative plus or minus 0.1 millimeter. So at normal print settings, PLA plus, it was within 0.02 millimeters. To me, that is awesome. And that was with a vernier micrometer. And that was the same on all sides. It was 0.02 millimeters. It's outstanding, that is. I've changed a few settings from the stock machine, but my machine, because it's open source, it has the latest flavor of the open source software, which is called Marlin. And it also could partly down to machine and the Prusa slicer. So what 3D printers available? Well, there's my machine. I've got one of those. Ender 3 Pro, cheap, 189 quid. Today's prices, which are quite good, I think. Punches well above its price point. You can print about 10 inches, 250 mil square, I think by about 200, 250 millimeters tall, so you can print a very big cube. It's true open source, so you can modify the firmware if you wanted. So it's tinkerable. It prints PLA, ABS, and PETG. Everybody manufactures upgrades for it. I've got some LED strip on mine, so if I'm printing something during the night, I can see from my phone what it's printing. I can see it's printing. And your firmware can be tinkered with, do anything you like. Over 1 million units sold. So very popular machine. And then their upgrade to that is the V2. Everything at the end of Pro, except it's got an LCD screen, proper LCD screen, and it's got a silent motherboard. That means you can't hear the stepper motors. So the stepper motors are silent. The drivers are better. But to me, having heard one, it's no quieter because the fans still make a lot of noise. And again, it can be tinkered with, and you can do what you like with it, really. And then another budget machine is manufactured by Elgu. The ones we sometimes get our Arduino Uno's Elgu boards, same manufacturer, again, PLA, ABS, PETG. The firmware cannot be tinkered with to provide extra features, but it does include a glass bed and a silent motherboard. And you can see there in the image how big I don't know how many days that took to print, but a long time. And there we have, that was in the Merck Journal, somebody, a Prusa i3. Now, at today's price, the £700, £780 including VAT, plus shipping, plus import duty. So if you decided you're giving yourself a nice big Christmas present, be wary of the import duty. It will print nearly everything. It's a top of a range obvious printer. Very good machine. It's what everybody else has based theirs on, really. And it's got good support. And your printer, what's it come away? It comes in a kit of parts. It's a kit. They don't come built up in a one cubic meter box. You'll get a base frame, your power supply, display screen, and a few extruded aluminium sections. And then you just got to put it together, a bit like an Airfix kit or a Merck kit. Very simple. Follow the instructions. Easy to do. Can't go wrong, really. And then I've got a budget machine. What upgrades can I do to make it better? Well, glass bed. That is my upgrade of choice, trying to recommend to everybody. That improves print quality completely, and the bed is truly flat. Because in all manufacturing tolerances, you're never going to have a truly flat metal bed. But when you've got glass on it, which is float glass, I don't know what the tolerance is, but it must be very, very, very tight and true flat. But remember, you need a space in the freezer when you got that. And then CR Touch, which is auto bed leveler with firmware. Now I've got a BL Touch, not a CR Touch, and it automatically adjusts the model file to take into account any fluctuation of the bed level. So mine goes around and checks 24 points on the bed. Then it's got the file from the slicer, and it looks and it compares the two, and it makes adjustments. So as it going round, sometimes the Z motors will work at one side of the bed to the other. With a Prusa slicer, I've not had a dodgy print. Both sides have been the same height on a wide print. So I'm quite impressed with that. But you've got to have a bit, unplug something and plug something in on the later enders. And then if you've got I've got a Raspberry Pi sat on mine. So this enables remote file transfer, monitoring and control. You've got an app. And say I printed something and then I decide I want to print it again. I don't have to start my PC or laptop up again. I can just print from my phone. Just select it. It's really, really good. And it updates. Fantastic. You can get add-ons as well, or apps that you can do other things with. But I've been using this Octoprint for quite a while now, and it's very good. And then some links there. all3dp.com, everything 3D printing, anything you want to ask, you'll find an answer for. And although it's got ads on, you can turn the ads off and they stay off. You don't get, it's very good. Then you've got Thingiverse, where you find loads of stuff to print, from a case for your mobile phone to whatever. I've included there some YouTube channel, Prusa slicer settings, Chep. He's the man for the quality printers. Anything you want to look at, Chep is the man. And another good one is Teaching Tech. But one thing I must say is that your 3D print will not be solid. It's a bit like you can adjust the amount of fill inside it. So like it's like honeycomb. So it's like corrugated cardboard, if you like, but you can increase or decrease the amount of corrugations you've got in that cardboard. And to me, coming from a structural background, that's brilliant, because you don't need a solid slab. You can just make it hollow with lots of supports in, and it'd be just as strong. So in summary, excellent prints, as we can see, can be produced on a good budget machine. Some DIY assembly and tinkering skills could be required. Yeah. Drawing in 3D required unless downloaded through a web. But you can get your grandkids, your kids, if they're at school, you know, they'll be doing 3D as part of school. You get them to do it. And there's plenty of free software for your use. And also plenty of YouTube content for help. Questions?